Hello, welcome back to the video lecture series for Introduction to the Art of Programming using Scala. We continue our look at some of these new collections, things that we hadn't used previously. In the last video we looked at buffers. In this video we're going to look at sets. Now sets basically come from the mathematical notion of a set, which is a collection of things where we do not allow duplicates and where order doesn't really matter. And so we can start off by creating a set, our standard type of thing here, set 1, 2, 3. Now, unlike the buffers from the last video, buffers existed in Scala collection mutable only. Set is a type that exists in both the immutable package and in the mutable package as well. So by default, when I create a set, I get an immutable set. And what can I do with this? Well, so for example, I can add something to it, but because it's immutable, it didn't change the original. What happens if I add something that's already there? Well, it's a set. That doesn't change anything at all. You can also take things out, okay, so that we get something like that. Let's try making a bigger set here. I've managed to put in 234s. You would think that random typing, though humans are horrible at random numbers. Now, part of the reason I wanted to do this is to show you that the second part, so we saw here that it does not allow duplicates. If you try to add in a duplicate, you just get back the same thing. I said that order does not matter, and sure enough, this 376 that was right in the middle when I created it from my list is right there. And if I were to take and run through res5, actually let's just do res5.mk string with a comma. Okay. That is the order in which it prints it out. And so when I put stuff in there, I don't know where it's going to come in the ordering. And if I were to iterate through it, res5.forEach println, okay, right now I'm getting them out in that order. And I have no control over that. That is, if you want to have control over it, technically there are sorted sets, and then you could, but in general you should not be concerned with the ordering of things inside of a set. So if the ordering is not significant, then this kind of begs the question, well, what happens if I do something like this? If I try to use it in a way where I do indexing. So what does res5 sub 4 do? And it returns false. And this might make you wonder, because you're like, there's no false involved here. This is this is a Boolean, but this is a set of ints. And you would expect from an array or a list or your buffer that when you look things up with indexing, you would get the value at a certain location, and that type that you would get back would match what it contains. That's not the case for sets. Okay, in fact, in some ways, because the order doesn't matter, that's not even meaningful for sets. What is meaningful for sets is to ask whether something is present. So this is literally asking the question, does the value 4 exist in this set? And the answer is no, it doesn't. There is no 4 in there. But if instead we ask if the value 58 is present, we will get a true. Okay. So this is some of the basic functionality of a set. This is the immutable set. What if I wanted to use a mutable set as well? And of course, when I do, as we saw earlier, I can't really add stuff in. And just to make it clear, if I wanted to add in the number 1, that's a reassignment to a val. Okay, so that is not a valid operation that I can do here. Now, had it been a var declaration, then I would be creating a new set and making the var reference point to that new set, and we could do that. But there is also a set that is in mutable. So I'm going to import collection mutable, just like I did in the last video. And that way, let's say, I'm going to just call it set because I'm highly inventive with my names, is a mutable set with 1, 2, 3. Even here you can see order does not necessarily matter. You have no control over that. Now with this set, I can do things like add in 78, and it changes the value of that set. I can look things up still, so I can say, hey, is the value 3 in here? But I can also do an assignment and take something out. Or do an assignment to true and put something in. Okay, so we have the ability to mutate things. By doing assignment, we can add things, we can remove things. Now, there are some other operations that you might want to, that might be comfortable for you in a mathematical setting when you talk about sets. So for example, the set, and yes, this is an immutable set. Okay, the union operation. Now, note I'm using the operator notation. This could also be written in this form here, in addition to union. So another operation that you should be familiar with is intersection, called intersect. So I can take two sets and see how they overlap. And in general, there's this whole set of methods that exist on the set, many of which, once again, are the same types of things that you're used to for sequences. So what happens if we do set.map okay. Remember, our set was a mutable set, and it gives us back a new mutable set where all of the, let's remember what our set was. Our set had 1, 2, 78, 99, and when I map it, I get back a new set, because this map, once again, has to work equally well with immutable sets and with mutable sets as well. Other interesting methods that are in here, subsets. Now, subsets gives me back an iterator for each print line, and this will show me all of the subsets that exist of the current set. This is an iterator because there are lots of subsets of any given set. You can convert between all of these things, so